guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And before any of you guys say anything in the comments, this is not an upside down 8, it's just how the font is. So it's not an upside down 8. So we have 3 to the power of a squared is equal to 81. Now, 81, well, this is what we want to do is we want to make these two bases the same. We have 3 and we have 81. And we want to change one of these bases so that they're the same as the other. Well, 3, it can't be simplified much more. So let's change 81, and 81, well, this is equal to 3 to the power of what? Well, 3 to the power of 3 is 27, so and 3 to the power of 4, well, that's 81. So x would be 4. So 81, I'm actually going to replace with 3 to the power of 4. So now we have 3 to the power of 4 is equal to 3 to the power of a squared. Now, because both of our bases here are the same, we know that our exponents here are the same as well, because if we have a to the power of x is equal to a to the power of y, this must mean that x is equal to y. So this means that a squared is equal to 4. So now we want to cancel out this power, so I'm actually going to take the square root, because remember, the square root is the opposite of the power. Now these two cancel out, and we are left with a is equal to plus or minus 2. Most people here would just say that the answer to this is 2, but it's actually positive or negative 2. So now this is our answer. Now I'm actually going to plug this in and check if it's right. So we have 3 to the power of 2 squared is equal to 81. 2 squared is 4, so we have 3 to the power of 4 is equal to 81. And 3 to the power of 4 is indeed 81. So we have 81 is equal to 81. And this is right. And the same thing for negative 2 squared. While taking the power of an even number on a negative number, we'll change it to positive, so this would be the same result. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 25 to the power of x minus 15 to the power of x is equal to 9 to the power of x. Now what I'm first going to do is I'm going to divide 9 to the power of x on both sides. So now we get 25 to the power of x over 9 over 9 to the power of x minus 15 to the power of x over 9 to the power of x, and this is equal to 9 to the power of x divided by 9 to the power of x is simply 1. Now 25 to the power of x over 9 to the power of x, this is the same thing as 25 over 9 to the power of x. And same thing with 15 over 9. This is the same thing as 15 over 9 to the power of x. So now this is equal to 1. Now 25 over 9, well, 25 is the same thing as 5 squared, and 9 is the same thing as 3 squared. So we could rewrite 25 over 9 as 5 over 3 squared. And this is to the power of x minus, now 15 over 9, this could just simply be simplified to 5 over 3. So 5 over 3 to the power of x. Now I'm going to let x equal 5 over 3 to the power of x. I get x squared minus x minus 1 is equal to 0. This means that x is equal to 1 plus the square root of 5 over 2. So now if we plug this in, we get 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. Now I'm going to take the ln of both sides. So now, because I took the ln, I can actually move this x to the front. So now we have x ln to the power of 5 over 3 equals ln of 1 plus the square root of 5 over 2. And now this can be written as x is equal to, well, for ln, we could actually write this, our ln 1 plus the square root of 5 over 2, we could write this as ln 1 plus the square root of 5 minus 2, minus ln 2. Because when you're subtracting to natural logs or even to normal logarithms, you simply just divide them. So this is the same thing as this. And now this is going to be over. Now the same thing for this. ln 5 minus ln 3. So this is our answer.